I had a question. So you have a model, and typically the models are not perfect, right? You have all these disturbances and nonlinearities that you cannot model perfectly the behavior of. So when you replay, do you actually, and over a long time, errors may accumulate. So how do you reconcile, or do you do that from time to time, or how do you ensure that somehow you are following some correlation or some closeness to that original model behavior?
Okay. So first of all, yeah, our model is the imperfect, as you can see. Yeah. But basically our technique use the recording the external disturbances separately, and the separately recorded disturbance will be applied during the offline, right? So that in that case, we don't need to perfect the model to estimate the prediction, estimate the physical behavior of the vehicle. That's one key feature of our technique. Another one is we also use some technique to synchronize with the actual state occasionally. So otherwise, the small error will be accumulate over time, and it will be, so the prediction will be deviate eventually after a long time operation. So we also use the synchronization technique to occasionally synchronize with the actual state and the model state and restart the calculation. That's the way.
Great, Doc. Thanks for the presentation. My question is, in your search algorithm, genetic search you mentioned, you're dropping some of the changes, right? So what if there's a point where there must be a legitimate change, otherwise there will be an accident? For example, increasing a parameter is the legitimate change that needs to be there. And the attacker changes the change and reduces the parameter, and that also causes the accident. So by dropping that change, you will not, how that would not be detected by just dropping that change, right? You see what I'm saying? Or I don't know if it's complicated, we can take it offline, but the question is, your search is dropping changes, but attacker may not just introduce a new change, but may modify a legitimate change. Mm-hmm. So dropping that change would not result in detection.
So yeah, in this presentation, I didn't explain the details for the continuous change, so yeah, for the continuous change during the genetic algorithm, we also need some additional heuristics. Yeah. So yeah, please refer to our paper for the more details. Yeah.
There's also a question on the Slack.
So the question from the Slack, does the disturbance observer assume that the sensors themselves cannot be hijacked? Or is there something ensuring the robustness of the sensors? And they clarify this by saying they asked because in the case of the Stuxnet attack, the PLCs did not work correctly, but the monitoring system thought everything was all right.
So first of all, in our technique, we don't assume the sensor is compromised or data on the log is not compromised. If we assume that case, we have additional step to first identify data is compromised or not, using some the data dependency or redundancy, like sensor fusion technique. So yeah, the compromising sensor or that case is totally different story. So we need additional step to identify first that case.